Every number in this course so far has rested on two assumptions we never actually tested. First, that the measurement is trustworthy, that when two people measure the same thing, they get the same answer. And second, that the data behaves the way our statistics assume it does. Most projects never check either one. This lesson checks both, using two tools we haven't touched. And it does it away from our project, in the workbench, because these runs belong to a demonstration rather than to the support ticket story. Down the sidebar, under Workbench, Toolkit, 34 tools, no project required. The same catalog running standalone with the runs saved to you rather than to an assignment. There's a whole lesson on that at the end of this chapter. Measure phase. Gauge R&R. Validate the measurement system before using it. The name stands for repeatability and reproducibility. Can one person get the same answer twice, and can two people get the same answer as each other? New run. And the hint tells us exactly what it needs. A balanced set, at least two parts, two operators, two trials, equal cells. Here's the study. A warehouse scale. 3 pickers, Anna, Ben, and Kara, 5 parcels, each weighed twice. 30 readings, and the format is 1 line each. Part, operator, trial, value. Tolerance goes in first. 0.5 kilograms. The width of the acceptable window. It's optional, but it unlocks a second verdict, and in a moment you'll see exactly why you want it. Save readings. 30 readings on file. 5 numbers. And 2 of them disagree with each other. %GRR, 10.2%. That compares the measurement error against the total variation between parcels, and under 30% is usually called acceptable. On that reading, the scale is fine. %P/T, 39.8%. That's the same measurement error, compared against the tolerance window instead. Nearly 40% of your acceptable range is being eaten by measurement noise. On that reading, the scale is not fine at all. Both are true. This gauge is good at telling parcels apart, and poor at judging them against a spec. And which one matters depends entirely on what you're using it for. The verdict the tool settles on is marginal. Then look at EV against AV. 3.1 against 9.7. Repeatability is fine. Reproducibility is 3 times worse. The disagreement is between the people, not within them. So the fix is a method and some training, not a new scale. Second question, does the data behave? Back to all tools, and this time the analyze phase, because normality lives with the tests that depend on it. Normality test. And we're going to use data you have already seen. The 33 billing first response times from Chapter 8. Back then I said they were right skewed, and that's why we cross-checked with Whitney. This is how you actually check that, instead of eyeballing it. Paste and save. Anderson Darling. A squared, 2.6198. Approximate p-value, less than 0.001. Reject the null. The data are not normal. And the QQ plot shows you why at a glance. If this data were normal, those dots would sit on the dashed line. They bend away from it at the top, and that bend is exactly what a long right tail looks like. Now the part that makes this useful rather than just discouraging. The Box-Cox transform searches lambda between -2 and 2 for the transform that brings the data closest to normal. Best lambda, -0.3. And look what it does to the statistic. A squared falls from 2.62 to 0.25. That transform data would pass comfortably. So when normality fails, you have 2 honest routes. Transform the data and use the normal theory tools on the transformed scale. Or don't transform at all, and use tools built for the distribution you actually have, which is what the non-normal capability tool back in Measure is for. Box-Cox, Weibel, and Johnson PPK per ISO 21747. What you don't do is run a normal theory capability study on data shaped like this and then quote the answer. 2 tools, 2 questions, and both of them belong before the analysis, not after it. Can I trust the measurement? And can I trust the assumption? It's worth being clear about what the Gauge R&R actually bought us. Not a number for a report. A specific instruction. Go and standardize how those 3 people weigh a parcel, because that is where the error lives. Next lesson, comparing groups when there are more than 2 of them. ANOVA, the non-parametric alternatives, box plots, and multivariate charts. See you there.